Greetings! This week we're still on grade 7. We're focusing particularly on the number system. We in 6th grade talked about negative numbers, but just more frequently how to place them on the number line. We're now actually going to work with them by adding, subtracting, multiplying, and dividing. There's two main ways that we're going to add and subtract, multiply, and divide them. I'm going to show you using a number line, which is the most common way, but then also using chips, positive and negative chips. You can get the positive and negative chips online and print them off, color them, and have them in front of you to use them for manipulatives, or there's an online virtual manipulatives that I'm going to show you through. So as a refresher, this is what we would have done in 3rd grade. The temperature one December morning was 3 degrees Celsius. It rose 4 degrees by the afternoon. The temperature that evening was 4 degrees Celsius. It dropped 5 more degrees by 6 a.m. the next morning. Show the 4 temperatures using the vertical number line. We're not going to use positive and negative chips because we're not actually adding or subtracting together, but one moment here. Okay, so if the temperature one morning was 3 degrees, we find that that is positive 3 on our number line. If it rose 4 degrees by the afternoon, we know that 3 plus 4 would give us 7. The temperature that evening was negative 4. So it just gives us a point, so we plot negative 4. Then it dropped 5 more degrees. So if it dropped, it's getting colder 5 more. So we'll go 1, 2, 3, 4, 5, ending up at negative 9. When you add positive and negative numbers, is your answer positive or negative? So let's review what are integers. Integers include positive and negative whole numbers as well as 0. Addition is the process of joining two groups, so an addend plus an addend equals the sum. So we know that anything to the right of 0 is positive, anything to the left of 0 is negative, and in case you didn't know, 0 is neither positive or negative in itself. But notice that anytime we move left, regardless if we're on the positive or the negative sign, we're moving in the negative direction. And anytime we move right, whether in the positive or the negative side, we're moving in a positive direction. Model the following on the number line and with positive negative chips. So let's say I have 8 plus a negative 2. So we start at 0 and we move 8 in the positive direction. Now we're going to add negative 2 to it. So we need to now go in the negative direction 2 units, giving us 6. 8 plus negative 13. So again, we'll start at 8. And this time we will add negative 13. So we need to go 13 in the negative direction. I should say 13. I was giving the answer, apparently. So we have to think about how far we would go. Well, 8 would be from 8 to 0, and then we would need to go 5 more to make our total distance 13, negative 13. So our final answer would be negative 5. Let's show this using virtual manipulatives. So the one in particular that I'm using is the one that's labeled virtual algebra tiles, base 10 blocks, and number lines. And I'm just going to click on the algebra tiles one, and I'm going to use the unit tile because I can turn them positive and negative. So I'm going to just bring out 2 of them here real quick, make one positive and one negative. We know that if we were to click these together, that a positive 1 and a negative 1 would make a group of 0. So just keep that in mind. But let's say we have 8, and we know that's positive 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And now we want to add more to our group, so we're going to add 2 negatives to our group. Well, I see then that I have 2 sets of 0 that would ideally just cancel themselves out, leaving us with 1, 2, 3, 4, 5, positive 6. Okay, so let's start with these 8 again. And we need to add in 13 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And all of these are negatives. I'm just going to go click on them once to turn them negative. Okay. Well, I see that I'm going to have a bunch of them pair up to be 0. Leaving me with 1, 2, 3, 4, -5 left over. I really like counters like this. It's a really great opportunity for students to get an introduction and to work with them. A number line, in my opinion, is more abstract, but it's still a visual model. So I like working with both of these with my students. All right, so we had -5 above. We did both of them with positive negative chips. It says now show the following using positive and negative chips. Okay, the first one is 5 plus -2. So I'm going to start with 5 in my group. 1, 2, 3, 4, 5. And I'm going to add -2 to my group. So I see that these create a group of 0, leaving me with 3 left over. Then I have -7 plus 3. 1, 2, 3, 4, 5, 6, and 7. Oops. 1, 2, 3, 4, 5, 6, 7. And then we want to add to it 3. Here we create a group of 0, so we have -4 left over. Another good one is, let's look at -6 plus -5. So let's start off with the -6. 1, 2, 3, 4, 5, 6. And then we want to add to it -5 more. 1, 2, 3, 4, 5. So since we are negative and we're adding more negative, notice that we don't have any groups of 0. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So -11. So at this point, I think you get the idea of how to work with adding positives and negatives and what makes a group of 0. You may try the rest and the remaining on your own. Use a number line to fill in the blank. Pause the video and see if you can't make this happen, and then come back. So the first statement I have is 2 plus what gives me -8. So if I were to start at 2, if I wanted to go -8, I need to go in the opposite direction to -8. So then I went a distance of 2 plus 5, so it'd be 7, plus 3 more. So I went a distance of -10 units to the left. -6 plus 1, plus what is -1? So I start at -6. I need to turn around and come back to -1, which is a distance of 4 units. So, excuse me, 5 units. So -6 plus 5 is -1. We can find sums of integers by thinking about distance and direction on the number line. Previously, we would have items such as 2/3 plus 5/3. So we would start at 2/3 and go a distance of 5/3 more to get to 7/3. But what if we're adding 2/3 plus a -5/3? So we would start at 2/3 and now we need to go in the opposite direction, or the negative direction, 5/3 units. So to go from 2/3 to 0 is 2/3 distance, and I need to go 3/3 more, continuing that direction. In both cases, we traveled a distance of 5/3. However, in one direction we traveled positively and in the other we traveled negatively. And once we approached zero, we had to think a little bit about how that would be affected. We can find sums of integers still thinking of their distances, but what if our denominators are not the same? Well, we know that we need to make them the same regardless. They need to have the same unit that we're talking about. So negative 2/3 plus 3/4 is the same as negative 8/12 plus 9/12. So we'll start at negative 8/12. We need to add 9/12 more. So to get from negative 8/12 to 0, we're moving in the positive direction, 8/12 of a space, but we need to go one more 12th to get to 9/12. So our final answer is 1/12. Similarly, thinking of 5/3 plus negative 2/4, if I start at 5 and 3/10, I need to go add a distance of negative 2 and 4/10. I know that I'm not going to quite reach 0 yet because 5 is much greater than 2. So ideally this just turns into a subtraction problem to get 2 and 9/10. However, if I were to start at 2 and 4/10 and subtract and add a negative 5 and 3/10, I would first need to go a negative distance of 2 and 4/10, and I would still need to go 2 and 9/10 more to get to negative, to add up to negative 5 and 3/10. So this would be negative 2 and 9/10. Complete the following using positive and negative chips. The first one was 10 plus 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. So you need 4 more to get to 17. 1, 2, 3, 4. Perfect. The next one was 10 minus 7. So here I have 10 and I need to subtract away 7. So 1, 2, 3, 4, 5, 6, 7. So we're left with 3. Then we had 4 plus 3. So there's 4 plus 3 more. 1, 2, 3. So a total of 7 units. And then the next one after that was 4 minus 3. So if we started with 4 and subtracted 3, 1, 2, 3, that would leave us with 1. This can also show us and help show us which direction we're going to go on if we're moving positively or negatively. So if I were to start at 10 with that first one, we ultimately moved in the positive direction because we added more positive to it, and we ended at 17. The second one, we started at 10 and we were subtracting, so we were taking away things, moving us in the negative direction. And we ended up at positive 3. The third one, we started at 4. Again, we moved in the positive direction because we were adding more to it. We weren't adding negative, we were adding positives, so we ended up at 7. And then the last one here, we started at 4. This time we added a negative 3, so we went negative distance, or subtracted, and we ended up at 1.